Okay, so the capstan base went down really well yesterday, and that's now all fastened in place. And now that's in and all the holes are drilled and so on. It should be pretty simple to install the rest of it, hopefully. The next thing is the capstan drum, which is the heaviest part. I think we can still get it up on deck using halyards. That'll just slot over the top and put the cap on, and then it'll be sorting out the machinery down below.
I prematurely took my gloves off. Last.
Wow, dude. That's it. Woohoo.
All right.
That one.
That was spin.
Damn. Oh my god.
Smooth.
That's so cool. Shall we engage the pawls?
Yeah. Okay, so this is part of the motor drive assembly from below the deck, which is going to power the capstan. This is the spool piece, which contains the drive shaft here. And we had to modify this just a little bit. We had to add another grease nipple or zerk fitting on the other side, because part of this is actually, there's some deck blocking in the way of where the original grease nipple was when this is fully engaged. So I had to take it apart to be able to drill and tap this. And just thought I'd show you guys how it goes back together, because it's pretty cool how well engineered this is. So this is the drive shaft that engages in the bottom side of the capstan. And you'll see there are some people concerned about water ingress through this hole, through the deck. And you'll see the way this is machined means it's actually pretty well sealed underneath the deck level. So it is possible that a little bit of salt water gets in and sits in these grooves. But this is all marine grade bronze, and that won't cause any issues. There are some little recesses to allow grease here, so it's possible that we get a drip or two below deck in the long term, which is not a big deal at all. So this shaft goes into the spool piece like this. We've got various rings here. These trunnion blocks here will stick out of these slots, and that is what controls the shaft going up and down. So I've got to put these in the right order. They're all greased up. And then there's this key which goes into the shaft here for the drive engagement from the gearbox. So that's all back together now. The shaft can rotate inside of this trunnion assembly, and then these little blocks will go in here, and then the lever arm from the control mechanism will engage and disengage this shaft by moving this whole assembly up and down. Very nicely designed and engineered by Dave Webster and Webster's Boat Machinery in Cornwall, UK. So this spool piece is going to go up through the deck and then thread into the underside of the capstan base and the upper spool flange, which is already bolted to the capstan base. Now this is a long stainless thread, and to prevent galling, which is when very hard metals in a thread just kind of stick, which is really bad. It happens easily with stainless, and it can be almost impossible to get it out again. So to prevent that, I'm using some grease, using moly grease, which is good for this kind of application. And I've already greased the male thread. The female thread is on the inside here. So I'm just going to get some of this grease on there as well. This particular grease is good for this because it's designed for high load, high stress applications where there's not repeated movement, because you wouldn't want to use this on bearings because it can actually wear the bearings faster if they're moving continuously. But for something like a thread, it's perfect. Also, don't quote me on that because I don't actually know very much about grease. And this thread should bottom out with this clocked in the correct position for the lever arm for the control mechanism to line up with these trunnion blocks. There we go, that's it. Now this is the control arm that controls whether this shaft is up and engaged or down and disengaged, and it hinges on a pin here, and then this end is controlled by the threaded control lever on the deck, and so when it pushes it down, pushes this end up, this engages into these little trunnion blocks, and that pushes the whole shaft up, and I should be able to push this up. There we go. So it's engaged, and I think I'm actually turning the capstan
The capstan?
now.
Should be.
Getting this in is a little tricky.
Nice. Damn.
Just fits.
It's insane.
That's crazy.
This needs to go in position.
That's the stuff that we like.
So now we've got the lever arm in and the pins. In a second we're going to lift this on, and it's heavy.
Wow. No. Really?
We've got to hold it up there while, I mean you've got to hold it up there while I get a couple of fastenings in the top.
Watch the varnish.
Watch that chain lock.
Yeah, right there. Oh my. Is that?
All right, should be able to gently release.
Cool.
So
Damn, that motor fits exactly. Wow.
got it? Yep. Okay, here we have the final piece of the top part of the capstan to install, and this is the cap piece, which was recast. So this is actually a new piece, although these bronze bits and the pin gears are all original. So hopefully we should just be able to put this on top and it'll fit over the key and it should be operational. Okay, here we go. Is it gonna fit? Wow! Wait, it does feel like it should go more, right? Because it's not. Hey, it's moving though. Oh yeah! Look at that. Oh yeah, perfect. Come on. Okay, so the capstan is in position, and it all fitted in remarkably well with the holes in the deck and the machinery underneath. So I'm really pleased about all of that. But there is one major issue, which is that the chain, unfortunately, is not fitting as it's supposed to fit into, we call this the gypsy or the wildcat, depending on whereabouts in the world you are. But this is the part which engages and holds the chain, and this was machined for this specific chain. So I was pretty surprised when it didn't fit, and there's a couple of possibilities. The gypsy was machined in 2 halves, and it was supposed to be 2 halves need to be touching each other for it to work. It's possible that there's a very slight gap in between, or it could be just that the gypsy isn't quite machined to the exact profile of this chain. Perhaps this chain is very slightly differently sized to the sample chain that was used to make this. Either way is surprising and potentially very difficult to solve, so trying to figure out what to do about this. Now, I was just looking at it, and I did just notice the bedding compound that the gypsy is bedded in has squeezed out a little bit, and there's a little bit of excess compound on there. So there's a very small chance that if I remove that, it could help the problem. So I'm going to try that first before we take this all off and start taking it to machine shops and things like that and get a bit drastic with it. So fingers crossed. I just die grinded just the areas where the bedding had squeezed out between the 2 parts of the gypsy or the wildcat, and if that was the problem, then we're in luck, and I'll be very relieved. If that wasn't the problem, we're gonna have to take this off, find a machine shop. It's gonna be a palaver. So we'll see. If this chain fits, I'm gonna be very happy.
What?
Okay, well, I think there's hope. It's not perfect, but it's a lot better than it was. I think that might have been a major part of the problem. Well, it was, obviously.
Did you just do what all the experts said not to do?
Yeah.
Experts hate him.
So I did a lot of very fine grinding and sanding on the gypsy to try and allow the chain to get into it, but it's still sticking. Just had another chat with Dave Webster, who made it, and I think one of the problems is that the chain we have is just very slightly different to the chain he tested on. So I think we can get it right without taking the gypsy off, which would be really hard to do, so that's a good thing. But I want to have it in a better position to work on it and measure it more precisely, so we're going to take it back off the boat and set it up horizontally on the dock, so I can take a bit more material off in a bit more of a controlled way. You're not very sweating it, so it's probably supposed to be.
Two thumbs up.
Grinding.
Yeah, dude.
Okay, so I'm grinding away in the sun down here, kind of hot, and I'm just removing material from the sides of the pocket because these chain links are very slightly wider than the ones that were used to make this. They're supposed to be exactly the same, but the welds on these ones are just not quite as precise, and so that makes some of the links a little bit wider, and I think that's one of the things which is making it stick. So I've been grinding this thing all day today and working on it pretty much all yesterday as well, sanding the gypsy before we took the drum off. And I think I'm finally getting somewhere, which is great. Just did the last little touch up here now, and I'm going to test the chain on it and see if we think it's good enough. I think we're in good shape. I think it's running about as well as it could right now. I did see one link sort of start to ride up a little bit, but I'm really cautious to take too much off here, because you can easily take too much off and make it so that the chain slips out under load with this type of windlass gypsy. So that's why it took so long as well. It's just going pretty carefully, gradually, bit by bit, testing it at each stage, because if you go too far, there's really not an easy way to add material. Got to get a whole new gypsy made, and then just getting this one off would be really, really difficult. So I think this is a good place to be. It's gonna wear in a little more as it gets used, and so I think we can get this back on the boat. Okay, ease. I would help, but only this camera's really heavy.
No, you got the heavy lifting. So we're measuring and marking the chain at increments of 45 feet, which is half of a shot. A shot is a distance that is about 90 feet. It's going to help us ensure that we have the right scope in our anchor when we're paying out anchor. It'll let us know how much anchor is out. Yeah, so I've got a little color-coded thing where I'm marking the chain every 45 feet.
Let's see it.
That was concise. You in electric mode?
Yeah.
How'd you know? Haven't done this in a minute.
I know.
Remember how to drive?
Yep.
So first we had to match the prop to the gear and all that stuff, right? Then the second part is matching the pulley ratios on the electric drive motors to the new prop also, and so we just finally got that. Right.
Yeah.
Yeah. At 100%, we're getting 2,600 RPMs on the motors, and that's just great. Pulling 175 amps, right where we want to be.
Perfect.
Yeah.
Alright, so this is the first test of the windlass. We're going to try and actually drop our anchor. We're going to try with using the motor first. See what happens. I'm going to test it coming back up before we put too much out.
Wow, dude.
The chain is sticking in the gypsy on the way out. We got a bit of a problem with that. Yeah, that did it.
Yeah, it's working great. Yeah.
I guess you got a job, Paddy.
20 and a half. 20 feet 6 inches.
How much is that in millimeters? Lowering the anchor. Twist it again, huh? Yep. Alright, well, let's bring it back up and then go under deeper water.
It's bound again.
Yeah, you're gonna have to keep pulling it, Paddy.
That is a really good luck sign. It's a super good omen. When it's the first time you've ever dropped your anchor and you grab some on it. Dude.
Who makes these rules up?
No, that's what all mariners know that. That's like a blessing. Got a crab pot. It's a blessing for sure.
Wow, look at that. Damn, bro.
Yeah. That's lovely. That is so nice.
Wow, I've got such good control over it
Awesome.
with this slow start.
Yeah.
Keep putting tension on. Like that. Okay, hold. Okay, now tension. So we're out in the middle of Port Townsend Bay right now, and we found that we've got some twist in our chain when we tested the anchoring, which is causing a little bit of a problem because as it's twisting, it's jumping out of the gypsy, the Wildcat, the sockets that hold it into the capstan. Now that twist is all wrapped up in the chain locker, so what we've done is come out to the deepest part of the bay, and we're basically letting all of our chain out, and then hopefully as we pull the chain back in, all that twist is going to come out. And what I'm doing right now is just using this devil's claw, which is it grabs the chain, and this is just a backup in case, because the chain is sort of jumping out of the gypsy a little bit as it comes around and the twist comes through. This devil's claw, if it jumps completely out of the gypsy, which I think is very unlikely, but if it does, the devil's claw will hold it and stop the whole thing from disappearing overboard. Nice. It doesn't seem to be jumping as often now. I think we've got through most of the twist.
So cool, dude. Alright, we're getting to the end of the chain.
Alright.
That's the end.
So the capstan is pulling our chain in and it's working pretty beautifully actually. We are having a slight issue with it sometimes sticking on the way out of the gypsy into the spurling pipe. So right now we've got someone down below putting a little bit of tension on it. I think we're probably going to need to add a chain stripper, but generally it's pretty amazing how smooth and how well it's working. And you can hear it's really quiet, really smooth. It's just pulling the chain in. There's hundreds of feet of chain down there, so there's a massive amount of weight on this assembly right now, and it's taking it all very easily. So really stoked actually that how well it's working so far. So we're just coming up on our green mark here with 2 white marks on either side, so that means this is 2 shackles or 2 shots. So that's 180 feet of chain. We're in 120 feet of water about, so we're hoping that all the twist we had in the chain is going to twist out as soon as the anchor is off the bottom. Right now it's kind of moving the twist down as we pull the chain up, but it's all nice and straight in between the gypsy and the bow roller, so I think it's hopefully going to work.
What?
How easily that comes over the roller.
With the shackle and everything.
Yeah. Well.
Amazing.
That was fun.
Nice work, dude. God, there's little paint glitter everywhere in the vacuum up here. You have the little Makita vac?
Yeah, we'll just do a big saltwater bucket wash.
Yeah.
So I'm down in the forepeak now, where you can see the capstan motor assembly below the capstan, and this is the gearbox. The motor's just behind here. There's a motor controller just in there, which has the brains of it. And this is all powered by our 48-volt batteries, which are under the companionway stairs. We don't need a separate battery for this because it's 48 volts. We can use relatively small cables, and then I just wanted to point out this whole thing is bolted through this piece of oak and this piece of oak, and then there's a bracket attaching it all to the structural bulkhead, and that's what stops this whole thing from rotating on the thread that attaches it to the capstan base itself. Now I want to say another huge thank you to all the people who have worked on this piece of kit. Keefe, who has some great videos on his channel Vintage Machinery. Really recommend you check them out, showing the restoration process of the old part of the capstan, the original part. David Webster from Webster's Boat Machinery in Cornwall, UK, who designed and made all this stuff down here connecting the motors of the capstan. Windy Hill Foundry, who cast the top piece, the cap. They also have a YouTube channel. And Dave Clark, who also has a YouTube channel, who made the pattern for the cap. Really grateful to all of them. Some beautiful work, and honestly I'm just amazed how well it all fit together. It's pretty incredible considering how far apart all these pieces were made, and how much design went into it, and the fact that none of it could be actually test fitted on the boat. It's really incredible that there weren't more glitches in getting it all installed. So I'm really grateful to all of those guys, and I just think it's so cool to have this original piece of Tally-Ho's deck machinery, which was on the drawings and on the boat when it was launched in 1910, and to have it back on the deck and working again with the addition of a motor is just so awesome, I think. Now, setting the anchor on Tally-Ho was really great, and the capstan just worked so well for it. The whole setup worked really well, actually. There is one little glitch we're still working out, which is that the chain is still sticking a little bit in the gypsy when it's coming off the capstan and into the chain locker. And right now, the solution for that is to have someone with their hands in the chain locker when we're pulling it in, putting a little bit of tension, pulling the chain down, and that seems to do the job. But obviously that's not a good long-term solution, so I'm going to make a chain stripper, which will be a piece of metal which just goes into the gypsy and stops the chain from going any further round than it should do. But other than that, the whole thing is working really well. The capstan was a bit of a gamble, really, never having used a capstan like this, and not knowing how the whole setup would work, and designing our own bow roller and so on. but it seems to be working really well. The anchor is stowing itself on the bow, and using the capstan, although it's a bit of a process, you've got to understand it and know what you're doing, it seems very functional. So I'm really, really pleased. So I will be trying to make that chain stripper before we leave, but very soon we will be leaving Port Townsend and heading up to the San Juan Islands for our cruise. Until then, thanks a lot for watching, and a massive, massive thank you to everyone who has donated or otherwise supported this project. It does make a huge difference. It means we're able to keep on doing this work, and we're able to keep on making and editing these videos. So I really, really appreciate it. And I'll see you next time. Cheers.